we're live. Okay, so we are going to start on chapter 20, and it's going to be a t-test for mean. Okay? So we're going to talk about what we call the student t distribution. Okay? It was discovered by a guy named William Gossett. And he was an Irishman. He used to work for a beer company, believe it or not. And it was published as a pseudonym of student T. And then people said, oh, that's pretty good. We're going to call it the T distribution. Okay? So, let's talk about rules. Number one, your data must come from a simple random sample. Okay? Number two, your data should be independent. And number three, the data should be normally distributed, should have no outliers. I'm going to go like that one. Number 4 and number 5. Your n should generally be greater than 30. Now, can you get away with smaller ones? Yes. Okay. In fact, what I will say, these two are kind of related. If you know your data are normally distributed, you can get away with a smaller sample than 30. But in the case of you guys and your projects, okay, a couple things that I would like to ask is, how do you prove your data are normally distributed? What did you say?
Graph it.
Graph it with what? What kind of a graph? A histogram. Okay? So you should be doing a histogram. Now, this is going to be very useful for your either speed limit, if you guys are doing a speed limit, or for your potatoes. Okay? Now, if you guys decide to do the potato bags, that's fine, but please don't select the same store for all 30 bags. Select a few different stores, okay? Because another thing is we want it to be independent, okay? If you select one store, is that really independent? No, it's that one store, okay? So I'd like multiple stores, okay? All right, so those are the rules. Now, the formula is T equals X bar minus mu over S over the square root of n. Okay? It's very similar. In fact, maybe I'll add that on here. Very similar to the Z distribution. Okay? The main difference is it has fatter tails. Okay? So, for example, if this, let's assume this is the Z distribution. Okay? I'll pull another black one out. Your T distribution is going to look like this. Okay? T distribution. Okay? So a lot of those same rules that apply to the Z apply to the T. Okay? So it's symmetric. It's symmetric about 0. The other thing that's different is it has degrees of freedom equal to n minus 1, your sample size minus 1, okay? And I will also add that the shape changes based on your degrees of freedom, df for degrees of freedom, okay? And really large samples get close to the z distribution, okay? So these tails will shrink if they get really large, okay? All right, so I think that's the main things I want to talk about today as far as the z distribution, okay? Now, what I would like to do is I would like to mix up a bunch of z's and a bunch of t's. Your homework is going to focus mostly on the t's, but your test, I'm not going to tell you whether it's t or z. Okay? So I will we'll start with a t, but then after that we're going to mix them up, and then you're going to have to tell me what the distribution is. Okay?
Professor?
Yes.
What does number 3 say again? 3 says what?
What does number 3 say? Sorry, I just realized that was off my board. Degrees of freedom equals n minus 1. Or are you talking about data should be normally distributed? There's 2 number 3s in there. Okay? All right. So let's do an example here. Okay? And the idea here is we're going to go through all 7 steps, just like normal. Okay? Hopefully we'll get through. I'd love to get through 3 problems. Think we'll be able to do that? Maybe 4. 4 if we're really lucky. Okay, here's an example. The CDC, Centers for Disease Control, says that the mean cigarettes smoked per day by smokers is 18.1. We obtain a simple random sample of 40 retired smokers to see if they smoke less. Okay? Our data results in a mean of 16.8 cigarettes per day with standard deviation of 4.7. Use alpha equal 0.10 to see if retired smokers smoke less. Okay? All right, so what is step number 1?
You list all the important numbers.
List all the important numbers. Okay, can you help me do that?
So
Just go through here. CDC says the mean cigarette smoked per day by smoking is 19.1.
I would say that's important.
That is important. Okay, what is that?
It's mu equals 18.1.
18.1, and why did you pick mu?
Because it's about population.
We assume that the CDC knows what they're talking about, right? Okay, so we think that's a population number. We obtain a simple random sample of 40 retired smokers.
I don't think that's,
You don't think that's important?
just because it's talking more about like the sample people and it's not. I
You
don't know.
don't think the sample's important?
Nah, I forget what I'm saying, sorry. I don't know.
I think that's important. Something's gonna equal
Yeah,
40.
it's N.
And that's
Yeah.
very important,
Uh-huh.
okay? All right, don't be blowing off important information. 40 retired smokers to see if they smoke less, okay? Our data results in a mean of 16.8 cigarettes per day.
I'd say that's important,
Okay,
and it would be X bar
X bar
equals 16.8.
equals 16.8 with a standard deviation of 4.7.
That's important
That's
too.
important also.
And it's sigma. Wait, no, that one is that? Or is that one? Who's the? I don't know.
Something equals 4.7.
Yeah.
Okay, so you said sigma. Who agrees with her that it's sigma? Sounds like she's having some trouble. 1, 2, 3, 4, 5. Who disagrees? 1, 2. Do you disagree?
Yeah,
What do you think it is?
I don't know, I just wanted to.
We just wanted to be a community. Clifton,
Yes.
you think it's S? Arthur?
Yeah, I think
You
it's
think it's
S.
S? Why do you think it's S?
Because it's like the sample, it's not known, I guess, it's like something that we got from our sample size.
Yes.
I agree.
Our data results, okay, so that's from our sample, right? Standard deviation is 4.7, so is this sigma?
No.
No, it's S. Okay? All right, so it's S. Use alpha equal 0.10. It's our first non-0.05, right? Okay, that was pretty easy to see if we're retired smokers smoke less. What is step number 2? Drew?
Figure out if it's categorical or quantitative.
Categorical or quantitative? What do you think?
I think it looks kind of quantitative.
Figure kind of look quantitative. Who agrees with them? 1, 2, 3, 4, 5, 6. Who disagrees with them? 1, 2. Carson, why do you disagree?
I would say it's categorical because they're seeing if they smoke less, so there's two options of smoke less or smoke more.
Okay, how about you?
I agree.
You agree?
Yeah.
Okay, well, Drew is right. It's quantitative. Okay.
So what's a key like indicator, like disprove that it's not the two categories?
Okay, so what we're measuring is retired smoke less than what? We've got to come up with a number, right?
Okay.
We're comparing, essentially what we're doing, we're comparing 18.1 versus our sample of 16.8.
Okay.
Is that less? That's the real question there, isn't it? Okay, and so an example of categorical would be comparing smokers to non-smokers. 20% of the population smokes.
Okay.
Okay, so I'm not going to say often, but not always, if you see a percentage in there, that's a good clue that it might be categorical. Okay,
Like saying like 20% of the population.
20% of the population smokes.
Okay. Cool.
That would be a clue that it would be categorical. But if, in this case, we're comparing means are always going to be quantitative. Okay? All right. Question number 3 is what? Isn't it great? You guys know all the test questions. Question is, do you know the answers? Okay? What's question 3? In fact, this will be probably your quiz question on Tuesday. Question number 3 is what, Maria?
Whether we know the standard deviation
No, I don't think that was it.
or
Is it a
that's how you know which equation to use, right?
Somebody said,
Find the O and the H one.
find the hole in the
Step four.
H1. Well, that's not what I said. Find the null and the alternative. All right. So the null and the alternative. Jose, do you know what they are? Remind me again, what does null mean?
So that's the hypothesis they give us. That's the way I move it.
Okay, look up your, what is the definition I gave you Tuesday? That's what I'm looking for. Mathematical statement,
Means no change.
no change, no difference. Okay? So what does no change or no difference mean in this equation?
Equal to simple sign.
And it almost always has an equal sign. There will be one case where it doesn't have an equal sign, but we'll cover that. We'll get there when we do it. But for now, we'll say always has an equal sign. Okay? So what do you think, Jose?
Mu equals 18.1.
Mu equals 18.1. Who agrees with Jose? 1, 2, 3, 4, 5, 6. Who disagrees? Okay, there's more than 6 people here. Okay, Jose was right though. Okay? What's the alternative? Alternative means statement we are trying to prove. What is the statement we are trying to prove?
Small less.
We want to see if retired smokers smoke less, and it's actually stated twice right there. We want to see if retired smokers smoke less. What's a mathematical statement that says retired smokers smoke less?
Mu less than 18.1.
Mu is less than 18.1. Okay, does that make sense?
Yes.
Okay? Everybody gonna ace this on the quiz on Tuesday?
Yeah.
Drew's like, no.
Forget it, man. No.
Okay? All right, step number 4. I think this is where Maria was trying to go. She was trying to skip a step. What was step number 4?
Do you know the standard deviation? To see which
Well,
equation.
you're still, okay, we're trying to pick the test statistic. You still keep jumping ahead. Okay? But the question is, I know she spoke so quietly, they didn't hear her on camera. Do I know population standard deviation? That's going to help her pick the correct statistical test. And the answer to that question is, Maria? You know
Not of the population, but of the sample.
we know the sample. Now, by the way, if you collect the data, you're always going to know the sample standard deviation. Okay? So, but we don't know the population standard deviation. Okay? Correct? Kennedy tried to get us off track here, but we don't know. Right? Okay? She's back. So, what kind of a test is this?
A t-test?
This is going to be our t-test. Okay? And that equation is off the board now, it's off the screen. For people at home who are watching,
X bar minus
x bar minus mu over s over the square root of that. Okay? So Emma, can you help me punch in those numbers?
So the T equals
T equals
16.8
16.8
minus 18.1
minus
over
18.1 over
4.7
4.7 over
over the square root of 40.
square root of 40. Is this big enough?
Yeah.
So that's something you should also be paying attention to. It's not something I asked you about. But yeah, this is big enough. It's 40, right? Okay. Now, you should probably still do a histogram just to verify. Because remember, central limit theorem is not this magical thing that just always works. We're assuming it because we're focusing on this, but you should always check your histogram. Okay? All right, so this comes out, let's that does no good, or does it do any good for the people at home? If I pull up my spreadsheet here, I don't know, I can't see it. Hopefully it's good. Okay, equals 16.8 minus 18.1, that's my numerator, equals 4.7 divided by the square root of 40 equals your numerator divided by the denominator. So I've got a t-score. Okay, now this is kind of like standard deviations, it's not exactly the same, right? But it's pretty close. Okay? Now, so I've got a t-score equal to negative 1.74. Okay? What is step number 5, Carson?
It's to find the p-value.
Find the p-value. And there's 2 ways to find the p-value. What are those 2 ways? You're going to need to know them both.
Using the table or the computer program.
We're going to use the table or the computer. Okay, we're going to do the table first. And this is something maybe we should have really gone to the library today. This is something you're going to want to see probably on video again. So be glad you're here because this isn't going to look very good on the video here. But let's go to here. Okay, now you got your normal distribution, you got your t-distribution. Okay? All right, so up at the top, now by the way, let me just share it, we can compare. Notice I've got this green area on the right. The normal distribution gives me the blue area on the left. Okay? So these are backwards from each other. Okay? Now, the idea here is I have in column C here my degrees of freedom. I'll try to blow this up a little bit so you can see it. Okay? Hopefully you can see that on video. I don't know if you can. You've got your degrees of freedom in column C, and you've got your alphas here in row 3. Okay? All right. So now, another thing that I should mention here, my degrees of freedom in this case are what? N minus 1, and my n is 40, so my degrees of freedom are 39. Now, I do believe, oh, by the way, my table is a better table than the one in the book. Okay? It has more options. So as we go down here, I need to go down to 39 degrees of freedom. This might not be in the book, but it is in here. So I've got 39 degrees of freedom on row 42 here. Okay, so I'm going to look at this row. Now, notice all these values are positive. Okay? However, we know that the t-distribution, just like the z-distribution, is symmetric. Okay? So the area on the left is the same as the area on the right. Okay? So I'm going to ignore the negative sign for a moment. Okay? But actually, here, let me do this again. Here, I'm going to draw a picture. Okay? Let's make sure, because another thing, remember, what's the question you should be asking yourself on question 5?
Does 1 or 2 tails?
Well, that's good. Is it 1 or 2 tails? That wasn't what I was looking for, but that, you need to know that. 1 or 2 tails. And how do you know?
By finding the p-value.
Clifton, 1 or 2 tails?
Look at what the question's asking. And our data results. There's
Okay.
less, it says on the left side.
It's a left-tailed test, okay? We also know that from our hypothesis right here, our alternative hypothesis right there, okay? So we're going to use question 3 to answer question 5. But I still can't believe you guys have forgotten the most important question. Am I going to have to give you a hint and put it on the board? What would Rick do? Of course, Rick would be drawing a picture here, okay? What am I drawing a picture of?
So is that really a question then?
It's a question that you should all keep in your minds constantly, especially when you get to question 5. Okay, what am I drawing a picture of?
Normally distributed.
No, it's not normally distributed. It is t-distributed, which looks a lot like the normal distribution, but those are fatter tails. Can you tell those are fatter? Of course they are. Good enough. Okay? All right, what is the mean of the t-distribution? We've already converted it, right? We converted it, so with this equation, we converted it to a mean of 0. Right? 18.1 is now 0. Okay? We want to see if they smoke less. We're doing a left-tailed test. We want this. Okay? What's this value here? 1.74. You can think of that as 1.74 standard deviations away. Not exactly the same, but it's close enough. Okay? So we need to find this area. Okay? We'll find that in a minute. Now, the problem is this table sucks a lot more than the normal table. Yes?
So if it was 2 tails, then that number would have to be divided into 2, so that it can.
Oh, that's a good question. If it was 2 tails, we would double it actually. Okay? So, and we'll talk about that in a minute, because whether you use the table or whether you use the computer, you guys, I think, are going to really like the computer, because you're going to go to the computer a lot easier. Okay? But quiz Tuesday is going to use the table, so you need to know the table. Okay? All right, so I've got 1.74. Okay? So what I'm going to do is I'm going to look on this line here, and I'm going to find where does 1.74 fit. 1.74, it fits in between those 2 values right there, correct? If I ignore the negative, do you see that? 39 degrees of freedom. Here, I'll highlight these 2 numbers here. It's in between those 2 numbers. Do you see that? Okay? And so because it's in between those 2 numbers, it is therefore in the p-value. Okay, this is the best you can do. Oh, we're not sharing this on the screen, are we? I don't know if you can see that anyway. Okay. So 1.74 is in between those 2 numbers, therefore your p-value is in between those 2 numbers. Okay, so if this is a quiz question, you're going to say your p-value is between 0.025 and 0.05. Okay, that's the best you can do. You can't find an exact p-value like you can on the z-distribution, unless you use the computer. Now, would you like to find an exact p-value? Okay, now, if you guys were going to come up with an equation for the t-distribution, what would you call it? T-dist, okay? Now, there's a few different commands you can use. And the one that I'm going to recommend is t.dist, okay? Now, what do you think RT and 2T stands for? Right-tailed, 2-tailed. So this one must be a left-tailed. The left-tailed doesn't say it's left-tailed, but it is, okay? So we're doing a left-tailed test, correct? On this one? So I'm going to use the left tail. Okay, my x is, here, actually, let's go over here. We've got it over here. Okay, so I've got my t-score here, equals t.dist, left tail test, put in my t-score, it says x, I should put a t there, right? That'll make more sense, okay? Comma, your degrees of freedom. How many degrees of freedom do I have?
39.
39. And then it's asking, do you want the cumulative distribution function? Now, I know it's been about a month and you guys have probably already forgotten that. What does cumulative distribution function mean? I don't know, that was the first week of class and I forgot. Or it was the second week, I think. It's the sum of all the probabilities up to 1.74, okay? So the idea here is, this is true. You're almost always going to put true on this, okay? And I got a p, so this is actually my true p-value. So this is the computer method, and then the paper method will say that the p-value is in between 0.025 and 0.05. Which one do you like better, the computer method or the table method? You don't like either one of them.
Real quick, what
You need to know both methods, okay?
for T-dis, what did you put in to get?
To get this number here,
Yeah, what did you
equals t dot dist, and then I have to choose whether it's left-tailed, right-tailed, or two-tailed. Okay? In this case, it is left-tailed, which isn't specified, so it's that one.
and degree of freedom?
You put in your x value first, or the t, this really is your t-score. T-score that we calculated in step number 4. Okay. Comma, your degrees of freedom, which is 39, and cumulative, you almost always say yes in our class. In fact, I think in our class, you can always say yes. If you take my 2040, you got to decide. But in our class, you can say yes, okay? So that gives you a value of 0.044, okay? Which is in between 0.025 and 0.05. Do you agree? Okay? Now, let's jump back to our steps here. So my p-value with the computer is 0.044. With the table, it's in between 0.025 and 0.05. Step number 6 is what? Buck, it must be your turn. What? What's step number 6? Do you have these all memorized yet? Here's what I'm going to recommend really quickly, okay? I'm going to really recommend you memorize these steps, okay? Then, when you're doing the problems, especially in chapter 20, just do all 7 steps, and then, based on all 7 steps, you should be able to answer any question that the computer throws at you, because you should have figured it out by all 7 steps, okay? So please do this first, and then answer the questions, okay? That will help you ace my quiz and ace my test, okay? All right, so Buck, question 6 was?
Reject or reject?
Reject or not. And what is the phrase that pays? You already forgot that thing? I know Jose remembers.
We,
If,
if the p-value is low.
thank you, that was Drew, right? If the
No.
p-value, oh, it wasn't looking, was that Carson? Oh, sorry, I couldn't see it. If the p-value is low, finish it,
Reject the,
reject, null. Okay? Jose laughs. You wanted to say the other term. Okay? All right, so Buck, is my p-value low?
yes.
Yes, it is, okay? My p-value of 0.044 is lower than what?
0.05.
Well, normally it's 0.05, but I'm asking you 0.10 this time, right? We're comparing it to our alpha. My p-value, 0.044, is less than my alpha. So therefore, with step number 6, I say,
Don't reject.
if the p-value is low, it is, therefore, reject. I know this is a hard step. Reject the null, okay? Now remind me, what does the null hypothesis mean? Jump back here for a second.
It's the one
Where's
that
my
they
null
gave you.
hypothesis? What does it mean in words? This is a mathematical statement. Go to the next one. It means there's no change or no difference. There's no difference between retired smokers and the rest of the smoking population. We just rejected that. We don't believe there's no difference. We believe there's a difference. Okay? And so Emma, make me proud. And what's step 7?
To write the conclusion in real words.
Write conclusion in English. And so the conclusion is in English is
I'm not too sure. I just know that we're not supposed to use like
okay.
null or hypothesis.
So let's go back to the question here. What are we trying to ask? We want to see if retired smokers smoke less. Answer that question.
So it would be retired smokers, not smoke. Or retired smokers smoke more.
Which one? You just said retired smokers smoke more?
Oh,
That was actually not one of the things I was thinking you'd say. These last 2 steps are hard, I know they are, especially because we haven't had very much practice with it.
Does it have to be something?
Okay, so
super
remember,
formal, or
let me go back to the null hypothesis. The null hypothesis said there was no difference between retired smokers and regular smokers, correct? We rejected that. We think there is a difference. What's the difference that we think?
we think it's
we think that they smoke less.
There is evidence that retired smokers finish it for me. Smoke less. Thank you, Drew. Okay. What's really frustrating for me, and I know for you guys too, is when I see students do all 6 steps correctly and then they trip at the finish line. Okay? This is hard, right? This interpretation stuff is hard. This is what makes this class hard. You can do all the math, you can get all the right numbers, and then you give me the wrong conclusion. Okay? So that's why I'm trying to go over this. No change, no difference. We've rejected that there's no difference. Therefore, there's a difference, right? And we think that the difference in this case is less than. There's evidence that retired smokers smoke less. Now, here's another clue that can help you with this. Okay? Okay, maybe I'll add it here. If you do not reject, okay, do not reject equals there is not evidence, not enough evidence. Okay, not goes with not. If you do not reject, there is not evidence of a difference. If you do reject, there is evidence. Is that helpful?
Yes.
Okay, so not goes with not. We rejected it, therefore there is evidence of a difference. Okay, does that make sense? All right, now, took a lot longer than I was hoping. Do you want to do another T or do you want to do a Z?
Just figure out what kind of it. Just give us a problem, not tell us.
Should I do it that way?
Yeah.
Okay. All right, I'm not going to tell you on this one then. Okay. I wish this cable was longer, because I would really like to do this on the computer. Maybe we should have gone to the library today. Is that, can somebody get on my YouTube channel and tell me if you can see this very well?
It's not focused.
I'll focus it in a minute. You're not a subscriber? Rick Bennett statistics and YouTube, and it should pop in there.
Or even if you just search his name.
If you go to YouTube, just do Rick Bennett statistics, and you tell me it usually pops up. Yeah, hit the bell and subscribe. And then after this class, you can unsubscribe on there. Says I'm live now?
Yeah.
Can you see it? I'm live now? Oh, yeah. I heard it. Oh, yeah. Okay, turn off the volume. Mute that. Okay, so can you see this though?
No, it's blurry.
It's blurry?
Yeah.
Well. Okay, well, here's what I'm gonna do. That's the best I can do. I would like to do this on the computer because I want to give you guys some computer help. Plus, this will help you with your statistics project, okay? All right, so I'm gonna speak out loud, type as we're going here. The Wireless Association says the mean cell phone bill is $50.64 in 2004. A market researcher believes the price is different today. He knows the bills are normally distributed and tests 12 subscribers to get the following results. See if the researcher is correct. Okay? All right, so here we go. 94.25, 70.07, 55 even, 38.94, 115.59, 76.05, 79.15, 77.56, 27.29, 56.78, 37 and a penny to 48. Okay? Now, this isn't one of the questions, but let me just throw it out there. What do you think of the sample size?
It's not too small.
Pretty small, right? Can I get away with it being too small in this case? Yes, because I told you it was normally distributed. Okay? So I'm going to get away with a very small sample size in this case. So you can get away with less than 30, but normally we like more than 30. Okay? And it does say right there, it's normally distributed. So you can get away with a smaller sample size for that reason. Okay? All right. So, Rachel, step number 1 is? Find the important numbers. Okay? What are the important numbers? Too soft.
The 50.64.
What equals 50.64?
The mean, so isn't it like mu?
Is it mu or x bar? Which one? Should we vote? Who says it's mu? 1, 2, 3, 4. Are you not going to vote, Rachel, for your own answer? Okay, who disagrees? Who thinks it's x bar? Okay, you're right. Okay? Even though you weren't sure, you were right. Okay? Why is it mu and not x bar?
It's the population.
So we assume the Wireless Association knows it's the population, right? Market researcher believes the price is different today, knows the bills are normally distributed, and tests 12 subscribers. What's 12? And by the way, it might be one to do this, mu and then 50.64. N is, what'd you say? It's 12? All right, are there any other numbers? You gotta find them yourself, right? What are some numbers that you might want to find yourself? The sample mean, which is X bar, and any other numbers you might want? What'd you say?
The standard deviation of the sample.
Standard deviation of the sample, which we represent with the letter
S.
S. Okay? How do I find X bar and S?
Equal average.
Equals average, and then you say
This.
Kirschville Gates? No, this is good. I had a student that would do that every semester. Kirschville Gates. Okay? And STDEV, right? Which one? S, right? We're using the sample. Okay, this is a sample of 12. Okay? Are there any other things I need?
We said the alpha is 0.05.
You assume that alpha is 0.05 because
Wasn't specified.
wasn't specified. Okay? Step number 2 is what, Colton?
Is the data categorical or quantitative?
Categorical or quantitative? The data in this case is
It's quantitative.
you sure?
Yes.
Okay, good. Scared me there, because it seems sure.
Just rereading this.
All right. Do you agree with that, Carson?
I haven't been paying attention, but I'm just gonna agree with it.
You're gonna agree with it. All right, so that means we gotta pick on you for question 3 if you're not paying attention. Question 3 is what?
Question 3 is to find the null and alternative.
Find the null and the alternative. The null hypothesis and the alternative hypothesis are
First one would be mu equals 50.64.
okay. Who agrees with them? 1, 2, 3, 4, 5, 6, 7, 8. Who disagrees? Buck, you didn't raise your hand.
I agree.
You agree, okay. All right. The alternative, he's correct, by the way. Alternative is
Would be mu does not equal 50.64.
mu does not equal 50.64. Why did you say that?
Because you're trying to see if he's correct. So it's not asking if it's higher or lower, it's asking.
Yeah, this
It
is
isn't
different, right?
50.64.
We don't know if it's higher or lower. Now, could you argue, well, look, my X bar is higher, right? Could I say that's higher? No, because you're supposed to do that before you look at your data. Okay? It just says different. When we did this, we didn't know if it was higher or lower. Okay? All right, so therefore, this is what kind of a test?
Two-tailed.
It's going to be a two-tailed test. Now, this is going to be interesting because we're going to show you some cool stuff at the end. Two-tailed test. Step number 4 is what? Kennedy, I think it's your turn here.
Step 4 is to pick the test.
Pick the test statistic, and you got 4 choices, right? I think I'm going to add a 5th one, by the way, but don't have to worry about it today.
And since it's quantitative, you just have to choose between whether the sample, if sigma is known or if it's unknown.
Is sigma known?
And it's not.
No. So therefore, it is a t-test. Okay? And that formula is
X bar minus mu
x bar minus mu
over S
over
divided by the
s
square
over
root.
the square root of n. And we'll underline that so it looks like it's a fraction. Okay? And then, Maria, can you punch the numbers?
Yes, so
Okay.
it will be 65.01
65.01
minus
minus
50.64.
50.64. Okay, that's your numerator.
And then for the denominator, it will be the standard deviation for the sample,
Which is
25
25 divided by
parentheses, the Oh wait, no, you don't have to do that. Okay. The square root of
Square root
n, which is 12.
12, which is a very small sample. But we're getting away with it because we said it was normally distributed. Okay? Hopefully this. Okay? Then we take our numerator, divide by our denominator, we're going to get 1.955. That's my t-score. Okay? Step number 5 is what? Fuck?
Find the t-value, p-value.
Find the p-value. Okay, there's 2 ways to do this. Do you know both ways?
Chart, or you can type equal.
Chart for the computer. Which one do you want to do first?
Computer.
Computer's going to give you the better number, right? Okay, what's the command?
Equals t-test.
T-dot. There is a t-test. You don't want to use t-test though. Don't use that one. T-dot. By the way, there's a t-dist, but I think t-dot dist is easier to use. T-dot dist, which one am I using?
T-test.
I'm using two-tailed. Now, oh, by the way, let me just mention something here. Okay, well, I'll mention it in a minute, okay? T-test two-tailed, okay? What do I put in here? What's X?
T-square.
Do you know, Buck?
No,
You want to phone your friend Arthur?
sure.
So my guess is that it's the p-value that.
The t-score that we just found right here is 1.95. Okay? Comma, how many degrees of freedom? Got 11 degrees of freedom. Okay? That gives me a score of 0.07. That's my p-value, right?
So the
Now, let me just mention something really quickly here. What if I would have gotten a negative here? So I'm going to put a negative on purpose. Watch what happens to my p-value when I put a negative in here. Doesn't work, okay? Now, if you get a negative score, just make it positive and then it will work, okay? But this command is always expecting a positive number. So if it's not positive, make it positive and it will work just fine.
Do you do the same thing with z-scores? Like if it's negative,
Z-scores? No. Z-scores, you don't have to worry about.
so if it's negative.
This is only for the t-score, and it's only for the two-tailed test. The other ones will take negatives. It's only for the two-tailed test that only expects a positive number. Okay? Now, do you know how to find this on the chart? This is going to be a little bit tricky here, but this was a good problem here. I didn't realize how good that was. Okay? That worked. Okay, so let's go back to my T here. We'll get rid of that coloring. Oops, never mind. Oh, I won't worry about it. Okay, so my degrees of freedom are 11, right? So I'm on this line here. Okay? I got a t-score of 1.955, right? So where does 1.955 fit on this line? 1.955. It all actually fits in there. That was weird. Okay? So according to this, it's in between 0.025 and 0.05, right? However, some of you here will say 0.025 less than p-value less than 0.05. Is 0.07 in between those two values?
no.
Okay, so what went wrong? Okay,
That was
this is a two-tailed chart, right? Or excuse me, this is a one-tailed chart, but I want a two-tailed test. Okay, so 1.95 does fit in here, and that means that the area in green is in between 0.025 and 0.05. And if I want this area over here, I need to double that. Okay, so this value, so I'm going to double these endpoints. It's really between, so 0.025 doubled is 0.05, and 0.05 doubled is 0.1. Now I've got the right value. Now let me show you something else here. If I did a t.dist right tail, okay, When we're doing a right tail test, I can take that number here, right? With how many degrees of freedom? 11. So that gives me a value of 0.038. If I take that value and I multiply it times 2, I just doubled it, right? So that gives me 0.076. So that's the exact same value I got right here. Okay? So typically when you get to the p-value, if you find one tail, just double the answer. And then it becomes a two-tail. Okay? Does that make sense? So this one was a good one. I was expecting, this one was a Z that I turned into a T. Okay? Because I didn't give you the population. It was on my paper, but anyway, this is a good one. Okay? All right, step number 6 is what, Emma?
Reject or do not
Reject or not. So what's the phrase that pays?
When the p-value is low, reject the null.
Okay, is my p-value low? What are we comparing my p-value to? Comparing it to my alpha, which is 0.05. Is my p-value low?
No.
It is not low. Not low. Therefore, reject or do not reject?
Do not reject.
Are you sure?
Yes.
There we go. That sounded confident. Do not reject.
We accept.
Oh, he used the A word. You're in detention, Buster. Okay? We do not reject the null. Do not reject the null. Okay? Step number 7 is what, Drew?
Probably say there is not evidence. Oh, you
Okay,
write
you're-
you write it in English.
Right in English. Okay?
There is not
There is not
evidence
enough evidence
that the price is different today.
that the price is different. Okay? Who agrees with Drew? Well done. Okay? All right. So, there you are. You want this spreadsheet? That's a good one, huh? This one was more like what you're going to have to do with your final project than the first one we did. I just gave you all the information. You're going to have to find all this out, except I didn't make you do a histogram. But y'all remember how to do that, huh? If you haven't figured it out by now, you're in serious trouble. Okay? You want me to save this spreadsheet? Okay. I will save this. I will post it. Quiz on Tuesday is going to be on chapter 20. All right. So the thing I was going to say. Okay, so Buck, you're going to get together with them and you're going to combine your data. I feel like a minute early. I feel like I should fill time, but I'll let you go a minute early. How's that? You want to try to meet in the library on Tuesday? Better? Okay. I won't tell probably Monday. Okay.